Kadisha, give me something that you noticed. Table 1, the y values increase by 5 each time. That is a true observation. What does it mean if it increases by the same amount each time? It is linear. So one of your notices could be that the first table is linear. Good. Because for each interval of x, and x is increasing by the same amount, the outputs are increasing by the same amount. Well, not as the x's, but adding 5 each time. Adding or subtracting the same amount each time is linear. So then, Bella, what's another notice? It could be about any of the 3 tables. So in the second table, our y values are multiplying by 2 each time. Class, what type of function is it if it multiplies each time to get to the next output? Exponential. Good. I'm glad we're recognizing that, especially since we just took our Unit 5 test. And a big skill in that was comparing these two. Braun, any other notices for you? Okay, you can't look at it now, maybe you notice something else. Even things that might not seem as significant to you might actually be significant because we're in a new unit now. So anything? Or wondering maybe?
The last would increase in the increase.
Okay, in our last table, it goes up. So 8, 9, 11, it goes up by 3. And then it like decreases and then continues to decrease. So increases, then decreases. Have we talked about functions that do that yet? Class. We haven't, so that's why this is a new unit. That's why we're kind of showing you some things that you might be able to recognize, and I'm glad some of us did. And then something new. All right, any other good notices or wonders out there that someone wants to share? I feel like we've covered a lot of like the big ones, so it's fine if we just want to move on. Other notices from other classes was that all the x values are the same. So when x has even intervals, meaning like it goes up by the same amount, it's easier to compare them and look for possible patterns in them. So we're gonna look at patterns that sometimes increase and decrease, or vice versa, decrease and increase. Not necessarily consistently going one way or the other each time. So today we are on the first lesson of Unit 6. And the goal today is just to find the rectangle with the greatest area. We'll do a few activities related to that. Unit 6 is called Intro to Quadratic Functions, and then Unit 7 is just quadratic functions. So this subject is going to be a main focal point for the rest of the series. And you'll see it again in geometry, you'll see it again in algebra 3-4. So if I could get you on board with like, I don't know, buying into it now, it'll make your math a lot easier moving forward. So today we're just easing you into it, creating drawings, tables, and graphs that represent the area of a garden, and then recognizing a situation represented by a graph that increases, then decreases. I'm recording right now, just like I do for every lesson, and it's always linked in the slides in case you ever want to work ahead or backwards. Puzzle piece is lesson 1. We have practice for practically every lesson, and I try to keep it under 10 questions, sometimes way under 10 questions. So please don't let yourself fall behind. This is a brand new unit, start fresh, doing this tonight. Try to do them the day that the lesson was given, or you just end up with a lot of work later on. The deadline for late work from Unit 5 already passed. Although I haven't gotten around to disabling it yet, so if you need to just submit some stuff really quickly, go ahead. I will disable it soon, but that's like lower on my list of priorities right now. my main priority, aside from, you know, getting everything ready for the next 2 days that I won't be here, is getting your retakes graded. Because I know like that's a big deal. It never really takes me that long to grade anyway. The policy is within 7 days that you turn it in. I imagine that I'll have time on the bus ride to Anaheim tomorrow. Hopefully I can get that all done. But say that you're like a spring athlete and you are currently at an F and you want your retake graded sooner. I could prioritize it for that reason, not necessarily just because your parents are on your case, like it'll be graded within 7 days. Maybe even by tomorrow, who knows? But if you are on the cusp of failing the next grade check, which I think is Thursday or Friday, then sure, you can email me and tell me that, but otherwise it will get graded in a timely manner anyway. So there's that. This will be probably the last time I can remind you that if you did not get full points on your binder check, you need to resubmit that as soon as possible. There's no reason you can't all get 100% on it. If you were absent some of the days or you lost some of the pages, all of the pages are over here. Find the ones that you're missing, go to Schoology, copy the notes, or rewatch the videos. But then when I go and check your binder again, I need to see all the pages. I don't memorize what every single person is missing. So that, please resubmit if you didn't get full points. I hate for you to fail because you didn't do well on a binder check. That's like the only thing in the 20% category, so you need to take notes and not lose. Quiz may or may not be Wednesday over the first few lessons, but we'll see. Just make sure you're ready, doing your practice every day, taking notes, all the things. Any questions on anything I said? Okay. So then on to the next activity, which is measuring a garden. Noah has 50 meters of fencing to completely enclose a rectangular garden in the backyard. We're going to draw some possible diagrams of Noah's garden, labeling the length and width of each rectangle. So, fencing. Where does fencing go in relation like to the garden? Describe it to me. Have we ever seen a fence? Please say yes. Are we alive? Okay, so where does fencing go in relation to a garden? On the perimeter of it, or around it is what I thought you would say, but really it would have to be relating to the perimeter. So what you want for each rectangle that you're drawing is you want it to have a perimeter of 50. That's how much fencing we have. And if you're not familiar with perimeter, how to find it? For any shape, it would be all the sides added together. Okay, perimeter of any shape is all the sides added together. So whatever diagram you are making, this time it has to be a rectangular garden. When you add up your sides, it has to add up to 50. So come up with, I'd say a minimum of 3, but as many that you can think of that have a sum of 50 for the perimeter. Couple minutes. No more than 2. So I forgot to review this, although I'm sure most of you are already aware. But for rectangles, and you'll definitely go over this more in geometry too. But the criteria for rectangles is that it has 4 right angles, which it does. And then the opposite sides, like the sides that face each other, are congruent to each other. The requirement for rectangles, and then like 4 sides. So, John, give me one of the combinations for the length and width. For the rectangular garden. If I need to have a perimeter of 50, what's the possible length and width I can have? Or can you give me at least a length and then we can problem solve the width? Okay, well, if I have a length of 25, then that means across the way would also have to be 25. What would my width have to be in that case, class? And is it really possible to have a width of 0? So let's adjust that a bit, pick a different length, something smaller than 25. Yeah, but just tell me like something smaller than 25. So a length of 25 is like where it no longer becomes possible, right? So you could have picked any length under that and problem solved it, Harley. Okay, so if I do a length of 20, and then across the way would have to also be 20, that adds to 40. And of course, these sides are also congruent. What would my width have to be? So that is one combination. We're gonna start adding these to this table, because we're gonna do something different in a second. But 20 for the length, 5 for the width. There's no like rule that the length always has to be longer. Like we could make the width, or we can make the length 5 and the width 20, but it's letting you know. John, do you have another combination maybe? Okay, 12.5, which means this would have to be 12.5, which means what would my width have to be, class? 12.5 also. So really, what kind of shape does this make? A square, but all squares are also rectangles. So squares have 4 right angles with the opposite sides congruent. So that still works. You can add that to your table if you didn't already. 12.5 by 12.5 does have a perimeter of 50. Good. Andre, give me another combination. 15 and 10. Good. When I add up all the sides, I do get 50, so that works. Jaden, give me another combination. Do you see like maybe a pattern at all? Maybe that can help you, or just problem solve it the way that we've been doing before. We know it can't be 25, it'll have to be something under it. 24 and 1. That would give me a rectangle. Didn't say that it had to be like other criteria other than adding up to 50 and making a rectangle. So that could work for sure. Brooklyn, one more combination. 20 and 5. We have that one. Do we have a different one? And also, guys, there is a pattern going on, if you're noticing, that all of these have in common. And maybe that could help. Does anyone see the pattern that I'm talking about? Michaela? So like if I add the length and width together, like just in our table, they're all equaling 25. So Brooklyn, can you give me 2 numbers that add to 25 that aren't already chosen? $23 and 2. They do add to 25. See if that would give a rectangle with the appropriate conditions. So add these together, we get 46. Plus 2, plus another 2 does give us 50. So good. And I'm sure there's tons of other combinations you could have, especially if you consider the decimals and stuff. You can't obviously have like a negative for this because You can't have negative length or width. But there's tons of other combinations you can have. For this next part, we're gonna use this table of values when it comes to the graphing. But try to identify the length and width of such a rectangle that would produce the largest possible area. So how do you find area of a rectangle? Length times width, good. So we have some lengths and widths. You can use your calculator to multiply them together. Go ahead, fill in this column for the areas. And then try to identify the dimensions that give us the largest possible area. We might not have already picked the one that gives us the largest possible area, so try to see if there's like another one you can do. But that's your task, fill in the area. Tell me which combination would give me the largest possible area. Caitlin, what's the area for a rectangle with dimensions of 20 by 5? Ryan, what about 12.5 by 12.5? Right. Jaden, what about 15 by 10? Oh, already told you. Eli C, what about 15 by 10? 150. Adriana, 24 by 1. And Joel, 23 by 2. Okay, so to answer, and you guys are all right, by the way, good job with calculated area, right? But to figure out the answer to the question for which rectangle would produce the largest possible area, see if you can notice yet another pattern. What happens when the numbers are farther apart? And what I mean, like from the length to the width, compared to when they're closer together. See, does the area get bigger or smaller? So from our table, our largest area is this one. Can anyone think of a rectangle that still adds to 50 for the perimeter that has different dimensions than this and gives us a bigger area? Or is this the biggest area? This is the biggest area. So what we're seeing is that as the numbers get farther apart, like 24 and 1 are pretty far apart from each other, still give us a perimeter of 50, but they give us a smaller area than as the numbers get closer together. And then when the numbers are the exact same number, basically making a square, that gives us the largest possible area. So the best garden that would have the most area would be the one that's 12.5 by 12.5. Remember that for your practice today, or just in general. As the numbers get closer together, the area is bigger. The closer it is to the square. Questions on this so far? So you're going to use your table that we made, and you're going to now graph these coordinates on this next coordinate plane. Ignore this one, because this was the one my first hour had. I'll snip it, but you have it on the front of your page. It wants you to plot some values for the length and the area. So from our first table, take some of the lengths and areas that we had, like 24 and 24, or 23 and 46. Those are the ones I'm remembering off the top of my head. And you're gonna plot those coordinates on here. And remember, length and width are kind of interchangeable. So like when my length was 24, my width was 1, I could also call that my length, and it has still the same area. So from our table, plot length and area onto this coordinate set. I'll freeze it so you don't just copy mine, but that's the task for it. and see what you can notice from the web. On the table, I put all the links and their corresponding areas, and I even included, if we just called the width the length as well, because it doesn't matter. It doesn't matter that one's shorter than the other, like, they can all be lengths, and they have the same area. You could have other combinations, if you had other diagrams and wanted to add that in, but so like, we're all on the same page, I'll just do from what we came up with together. So when you graphed it, you might have noticed a certain pattern. If you don't know how to graph, I'll graph it really quickly, long. But 24, 24 would be here. 23, 46 would be about here. 12 and a half, 156.25 would be about there, maybe a little lower. 1 up 24. 20 up 100. 5 up 100. 15 up 150. 10 up 150. And 2 up 46. And of course, depending on what other dots you have from your other combinations that work, you see something about this. What are we noticing about how it looks? Josh, can you tell us? It goes up and then down. And we haven't seen a pattern like that necessarily in linear or exponential, where it's not just going up or it's not just going down. And then, how would you guys describe this shape? Rainbow. Kind of like a rainbow. I prefer more like a U shape, and that's characteristic of our quadratic function. I don't know if the lesson really wants me to tell you that yet, but I'm going to tell you because that's what it is. Quadratic functions is our main focus for this unit and next unit. So when we have points in a U shape, whether it's down like a frown or up like a smile, those are our quadratic functions. They have their own special formula, but that's not our main focus today. It's just plotting them and seeing that it has a pattern. So it said that it wanted you to plot some values for the length and area. And we've had a table already with some lengths and areas. So if you just like cover the middle column, I'm plotting 20, 100, 12.5, 153.25. Does that make sense? And then because it doesn't matter, like that one has to be shorter than the other, I could also just cover this and plot these. Like these could all be lengths too. Does that make sense? And then what you also could have noticed is that the ones from the same rectangle are right across from each other. They have the same area, like these two. Both had an area of 24, so they're on the same height. What was our maximum area? Karen, maybe, what was our maximum area? And then notice since that one is our highest point of our arch, like our turning point, there wasn't two that had the same area because it's the same input that gives the function. Okay, everyone with me so far on the coordinates, where they came from, type of pattern it makes. So lots of things that you can notice. Next question. The points 366 and 2266 each represent the length and area of the garden. We're gonna plot these 2 points right now, because we have not already done so unless you did on your own. So 322. Maybe if I move this dot over, it'll look nicer. It would be like about here. And 22 up 66 would be about here. So do they still follow like our archy pattern? U-shaped pattern? So it says, what do these points mean in this situation? So, Jack, I'll call on you. What is the 3 representing in this situation? Okay, good. So a rectangle or a garden with a length of 3. That could be you're interpreting it. If you guys want to write this down for the 3. So a garden with length of 3 meters. And then Cranky, how do we interpret the 66? So we can say a garden with a length of 3 meters has area of 66 meters squared. All right, we can recognize this as a coordinate. If we read our x-axis, it says length. Our y-axis is area. That's what you should do, is it's telling you it as a coordinate and wants you to interpret it. Good, questions on that? And then for the 22, you can just replace it here. The area is still 66 meters squared. Yes. We'll add you to the line. I'll add you after. All right, last question. Could the point 125 represent the length and area of the garden? Don't say your answer out loud. But it's based on all the trends we've seen today. Maybe problem solve it some sort of way. Could 125 be a length and area? Think about it yourself. Share. Haley, could that point represent the length and area of this garden? And why do you say no? Okay, so earlier we already talked about if the width or length is 1, what does the other dimension have to be? Class? If the length or width was 1, what does the other dimension have to be? Make it have a perimeter of 50, it had to be 24, right? So if we make it now 1 by 25, does it still have a perimeter of 15? All right, so that could be one of the ways you explained it. You could also say, like, according to the pattern, like we saw that these add to 25, 1 plus 25 is not 25. If you graphed it, it wouldn't follow in our nice U shape. Probably with the graphing calculator, you'll see that more. There's lots of things you could say. But this alone would not give you the correct perimeter. It does give you an area of 25, but doesn't give you the correct perimeter for this situation. All right, good. Any questions? And that was really it. The goal today was to find the rectangle with the greatest area. We're seeing as the dimensions get closer together, more like a square, the better the area is. Remember that for your practice and moving forward on the lesson. You have a puzzle piece that you can work on for about 15 minutes, maybe even finish it. Lesson 6.01. You can even work ahead because everything's already posted for the next few days.